Towering over the Indian subcontinent is nature's greatest geological marvel, the Himalaya. These skyscraping peaks have a unique story of birth and evolution. As the youngest mountain ranges on the planet, they are continuously in a state of geodynamic change. In India, the Himalaya holds great significance. Millions depend on the complex interactions of exogenic and endogenic processes for their sustenance. For over 50 years, one institute has worked tirelessly in some of the most challenging terrains and environments in the world, conducting structured investigations of its orogenic geology and natural resources, mitigating natural hazards like earthquakes, landslides and floods, and guiding us in responding to climate change. The Wadia Institute of Himalayan Geology. Dehradun, in the Indian state of Uttarakhand. This is the site for a center of excellence and one of the world's premier institutes for Himalayan geology. The Wadia Institute of Himalayan Geology, an autonomous institute under Department of Science and Technology, Government of India. Experts and researchers from all over the world come here to conduct cutting-edge scientific research.
This institute's mandate is to do geoscientific investigation for the natural hazards, for the natural resources, to understand some of the phenomena taking place into the subsurface like geodynamics, climate variability, biotic evolution, how the material from the subsurface are coming up through exhumation, and what are the different type of implications it is providing to the seismicity, earthquake occurrences, to the landslide occurrences into this region, as well as the most important thing that it has got the glaciology.
The story of Wadia Institute of Himalayan Geology began over 50 years ago, in large part thanks to the passion and drive of Dr. D.N. Wadia.
He worked in Kashmir, Himalaya in those days early, and had a major contribution. And he produced very fundamental, very important work on Himalaya. Because of his work, he was awarded Fellow of Royal Society. After his retirement, he thought that Himalaya is not very explored that time, and also very difficult terrain working in those areas. So he thought it needs a special effort to study the Himalayas. So that's why he wanted that it should have a separate institute for the study of this mountain belt.
On the 15th of January 1965, the Government of India accepted a need for a research facility that focused on Himalayan geology. A Grant and Aid Institute was registered as a society on 21st of May 1968, and certificate of registration was issued on 29th of June 1968. The first governing body of the institute, with Professor D.N. Wadia as president, was constituted in 1970. Some of the following objectives are: to conduct training and research on Himalayan geology based on tectonics, geomorphology, glaciology, and hydrogeology of the region; to prepare geological maps of Himalaya and conduct studies based on them; to host research fellows and investigators from both India and abroad. In 1969, with the demise of its beloved founder, the institute was renamed Wadia Institute of Himalayan Geology. In 1976, the institute was shifted from the shared laboratories of Delhi University to its own dedicated campus in Dehradun. It was a new chapter in an illustrious journey that would take geological studies to Himalayan heights. Today, Wadia Institute is actively pursuing a multidisciplinary approach to study orogenic and mountain building processes in the Himalaya.
For the next 5 years, we have launched a new program. That program is defined as CAP Himalaya, this acronym. And if we expand it, it says that characterization and assessment of surface and subsurface processes in the Himalaya. This work, what we have taken, it will provide some sort of implications based on different geoscientific disciplines. It will address these issues of the geodynamics of the Himalaya, seismogenesis of the Himalaya, natural hazards that can be caused by earthquake or landslides or floods, or maybe glacial related outburst flood. Other aspect, we have decided through this CAP Himalaya program, we will look into the health of the Himalayan glaciers. That is very, very important. Then there are a lot of important phenomena going on in the subsurface. Mantle upwelling, there will be some sort of paleo events has taken into the past. We like to understand sedimentary process as well as the climate variability. So all these things will come under one umbrella.
This mission mode program has 11 research activities interwoven into its primary goal. Arguably, our knowledge about Himalaya has grown in leaps and bounds in the last 5 decades. Wadia Institute has been key to this, with far-reaching contributions in mapping the Himalaya, conducting integrated studies on Himalayan glaciers, researching seismic networks and earthquake studies, landslide and flood hazard studies. Mapping was one of the first challenges undertaken by the researchers of the Wadia Institute. And it was no easy job.
When we came here in Wadia, that time there were no laboratories were there. So initially we started to focus on very remote areas. So we took up Arunachal Pradesh and Ladakh. We have been working in the Pangong Tso, then Somwarari. Even our teams were sent to even Karakoram Pass and Shiok region and Dst-Wihg only that time.
Thanks to these exemplary efforts, major contributions have been made by producing regional geological maps for northwestern and northeastern Himalayas, covering rugged and remote regions of Kashmir, Ladakh, Himachal Pradesh, Uttarakhand and Arunachal Pradesh. The Institute has also produced a 1:50,000 scale geological map of Itanagar Capital Complex. For its home state of Uttarakhand, Wadia Institute has developed a web-based portal showing active faults in the region. These maps have helped immensely in understanding and developing newer concepts of mountain development, in seismogenesis, and in earthquake and landslide hazards. An increasingly hot topic in recent times has been climate change. When it comes to forecasting its impact on the subcontinent, all eyes turn to the Himalaya and its glaciers. The Indian Himalayan region is often described as the third pole or the water tower of Asia. It contains 9,575 glaciers spreading out across 40,000 square kilometers. In 1985, the Wadia Institute initiated studies in the Himalaya Karakoram glaciers, embarking on multidisciplinary and multi-institutional expeditions between 1986 and 1989. Between 1991 and 2003, teams monitored the Dokriani and Chorabari glaciers.
We ran a glaciology study, Dokrani Bamak Glacier. For 10 years, we monitored around the year. This study, we were the first to find out that there was a recession of 20 meters per year. And now this data became internationally recognized.
This data regarding the rate of glacial recession was used as a seminal reference for the UN Global Climate Programme. It underscored the critical importance of doing research dedicated to glaciology. 4th July 2009. The Center for Glaciology is established at Wadia Institute of Himalayan Geology, Dehradun. Currently, the institute is monitoring 10 glaciers in Uttarakhand, Himachal Pradesh and Jammu and Kashmir, as well as 3 glaciers in Karakoram. Data from these studies help create response models for the better understanding of hydrological cycles and budgets. These studies archive one of the longest time series datasets on glacial responses to weather parameters. They have also produced a glacial lake inventory of Uttarakhand and Himachal Pradesh that is pivotal in understanding and mitigating the glacial lake outburst floods hazard.
This is the last habitable place in the Gangotri Valley, Bhojbasa. And we have installed one athlometer, which I was telling you, we are monitoring carbon aerosols in the atmosphere and how these carbon aerosols are going to impact glacier melting in years to come. The other facility which we have is a small establishment which we took over from UP Council of Science and Technology through Ministry of Science and Technology. Here we are analyzing rainfall pattern, then glacier melt, snow melt, ice melt. So all the 4 components. The basic objective of this entire exercise is to understand the source of snow in the Gangotri Valley.
Knowledge is power. With these studies, Indian and global communities can gather more tools to inform themselves about climate change. Perhaps one of the most dramatic and earth-shaking features of the Himalaya geology is its unique seismic nature. As the planet's youngest and most volatile formations, these mountains have far-reaching consequences on populations even hundreds of kilometers away. Wadia Institute has dedicated countless research and fieldwork hours to unlocking the mysteries of Himalaya's seismicity and seismic networks.
We set up a network of seismic stations in Kangra region, seismic. So that which was started that time, now it has grown. We have got in this institute monitoring more than 30-40 stations, and all this data which we otherwise used to send our people and bring the data from say different places to Dehradun. Now all this data comes through satellite, and data is online, data is received. So this is a very long way of the monitoring of seismic activity.
Our studies have focused in understanding the process of seismogenesis, what causes earthquakes, and which are areas which are more vulnerable, where future earthquake can come and other things. And having learned this, the major challenge is whether we can predict the earthquake, and if not, how to mitigate these things. So we have taken a major initiative in augmenting the monitoring network. We have put up a station in the higher Himalayan side.
In 2005, Wadia Institute established a network to monitor the seismicity pattern of the central seismic gap, comprising the regions of Garhwal, Kumaon and Himalaya. The network consists of 54 broadband seismographs, 16 accelerographs and 15 permanent GPS stations. Another area of frontline research has been the exploration of deep earth structures of the crust and lithosphere, where magnetotelluric and passive seismology studies define the geometry of the main Himalaya thrust, or MHT.
It is the MHT, the main Himalayan thrust, that controls that locales of the large earthquake. So we need to understand the geometry of the MHD so that we will be able to delineate which are the places where major or great earthquakes are anticipated.
We have launched a special program or monitoring imaging the internal structure of the earth. We image our interior of the earth in different physical parameters like density, velocity, and electrical properties of rock. That has given us the very good idea on the top of the downgoing Indian plate, what is the geometry, and where mostly large earthquakes occur. So having understood this process, our major challenge is how to predict earthquake.
In order to pursue this question, Wadia Institute has worked on earthquake warning systems, a highly complex field of study that is still refining its technologies. In 2006, the Institute opened India's first multi-parametric geophysical observatory at Ghuttu Garhwal, Himalaya, to generate high-resolution earthquake precursors.
Now we know that there are several parameters, and every parameter has at least one or two success stories. But when it comes to prediction, none of the parameters is diagnostic of fundamental parameters. So to take a lead in that aspect, we have established a multi-parametric geophysical observatory at Ghuttu, where instead of one or two parameters, we are monitoring 11 parameters simultaneously. And that is a major lead, to my mind, which Wadia Institute has taken.
This observatory was able to record precursory data for the Kharsali earthquake of 2007 as well as the 2015 earthquake that hit Nepal.
We have to mitigate how to minimize the damage. So we have also started a microzonation studies which help us to understand in case earthquake comes, what will be the order of oscillation, ground acceleration and other things. And we have already prepared such maps which can be used by engineers, that building which they construct will be able to withstand these things. And most important aspect is public awareness. What to do during earthquake period and what not to do during earthquake period. And the basic place to learn these things aspect is school. So Wadia Institute had started a program which we called it HIMSELF, Himalayan Earthquake School Learning Program, where we had set up a 54 station in the schools, and that motivated students to see when earthquake comes, what kind of a vibration take place, how do we estimate the magnitude, how we estimate where the earthquake has occurred. So that knowledge has gone into the students.
But earthquakes aren't the only natural hazards that Wadia Institute is developing mitigation systems for. Every year, Himalayan regions are assailed by flooding rivers and devastating landslides. Wadia Institute has produced the largest database on Himalayan rivers. It comprises details on the Indus, the Ganga, the Brahmaputra, and their tributaries flowing across full climatic and tectonic spectrum of Himalaya. Studies trace their chronology, sedimentary architecture, and landscape evolution. These studies help the Wadia Institute in performing a critical social service, providing warning data and mitigation systems to government agencies so that there is minimal loss of life and property. Researchers have played a leading role in treating chronic landslides at Varunavat in Uttarakhand. In 2013, the Wadia Institute of Himalayan Geology played a pivotal role in understanding the devastating Kedarnath floods. It launched Manu, or Mapping the Neighborhood in Uttarakhand, a novel initiative by Department of Science and Technology to prepare guidelines on alleviating societal vulnerabilities during large floods. All of these efforts have put the Wadia Institute in the League of India's premier research facilities, with a string of notable success stories. Success is defined not by contributions to science, but also service to society. On both fronts, the Wadia Institute has taken great strides. The Wadia Institute has hugely impacted the story of the Himalaya by establishing fossil records and updating its evolution of life. In 1983, index conodont fossils discovered in the lowermost Thal beds fixed the age of the highly contested crawl belt as late Precambrian to Cambrian.
This has changed the way we look at Himalayan structure as well as stratigraphy. This also led to redefine the Gondwana reconstructions as well as the global biotic correlation. So that made a tremendous impact to the world scenario.
The Wadia Institute of Himalayan Geology, an autonomous institute under Department of Science and Technology, Government of India, has paved the way for Indian geology to grow in leaps and bounds. And one need only a walk through its museum to take a journey through time. Or drop by its library, home to one of the biggest and most comprehensively curated collections on earth sciences. Knowledge resources like these, as well as state-of-the-art lab facilities, have made Wadia Institute destination of choice for national and international researchers. For an institute that concerns itself so much with the past, Wadia Institute is equally invested in building the future of Indian geological sciences. Scholarships are offered at doctoral and postdoctoral levels. Summer and winter internships are offered to students who get mentored by senior scientists. Its illustrious legacy is in the safe hands of the next generation. What kind of science and social impact can we hope to see coming out of Wadia Institute of Himalayan Geology?
The future is very bright. Last 50 years, lot of knowledge has been gained, but still lot much is remaining, particularly in understanding the subsurface process and its relation to the surface process. That's why this CAF Himalaya has been evolved. The linkage between subsurface and surface will provide a greater understanding about the phenomena, what is happening into the Himalayan terrain.
50 years of benchmarks, 50 years of paradigm-shifting discoveries, and excellence in research. Wadia Institute of Himalayan Geology has performed an invaluable service to our collective knowledge about these extraordinary landscapes. May the next 50 years bring glory even more.